All right, guys. So now we are on a second question on the resonant frequency, actually. So from this problem, we can easily see that we have a circuit contains a 100 microfarad capacitor. Now, please take note of this. Now, we're going to start now. So let's start. Solution. Now, so we have capacitor, so that is a C, 100 microfarad. Oh, please, this is very, very important. You need to convert this guy. So that is 100 times 10 raised power minus 6 farad. Please don't forget to do something here. Now, in standard form, to make it work easier, this is 10 raised power 2, right? And that is 10 raised power 2. That is 10 raised power 2 times 10 raised power minus 6. Now, of course, that will be 10 raised power 2 minus 6 is going to be minus 4 farad. Please take note of that. Very, very key. Like, you need to do your conversion and so that you make it work easier. So your C is 10 raised power minus 4 farad. Now we move on. The resistor is 10 ohms. Okay. Resistor is equal to 10 ohms. And of course, we have the inductor. So the inductor, that is L, is still L. All right. Now we're told that they are all connected in series, And I said, if the resonant frequency of the circuit is 100 hertz, so the resonant, that is F naught, is 100 hertz. That find the value of L. Okay, so we're looking for L now. So this we're looking for. So find the value of L. And don't forget from our previous formula that I gave you earlier that our resonant frequency F naught is 1 over 2 pi the square root of 1 over LC. All right, so now from this problem we have here, we are told we know our F naught and we know our capacitor, but we don't know our C. So we don't know our L rather. So we know our capacitor, we don't know our L, which is the inductor. So we're told to look for L. So in that case, I can easily say that why not let's make L the subject of the formula? Yeah, to make it work easier, why not make L the subject of the formula? So let's try and do some mathematics here. So the best thing, let's start with this. So let's square both sides to remove the square because what you're looking for is in the square root. So the first thing you can probably start with is let's square both sides. When you square both sides, then you can easily find your L. All right, don't put in the parameters yet. Don't put in the parameters yet. Just try and square both sides and see what you're gonna get out of it. So square both sides. Square both sides. Now when you square both sides, I'm gonna be having F naught square is equal to 1 over 2 pi all square brackets the square root of 1 over LC all square, because we are trying to square both sides, right? So now let's go on. Now F naught square still remains F naught square, so F naught square is equal to 1 square is 1, 2 square, because this square is affecting everything here. So 1 square is 1, 2 square is 4, and of course pi square. Take note, pi square. Now this square cancels this square root. Yeah, that is the reason why we're trying to square both sides, because we want to cancel out the square root. If it is cube, if you have a cube root, you're going to cube both sides. So, but now we have squares, then you get to square both sides. So now the square root cancel out, the square cancel out the square root. So I'm left with 1 over LC. Ooh, this is very easy now. Very easy. So you can easily make L the square of the formula. So let's go on. F naught square is equal to 1 times 1 is 1. Then you can multiply these denominators here. So you can see that is 4 pi square LC. Okay, why not let's try and cross multiply. Cross multiply. I'm doing this so that I can easily make that easier for myself. So when you cross multiply, you're going to be having 4 pi square, that is these two together, 4 pi square LC F naught square is equal to 1. Yes, that is what you will be having. So be having that. So let's do something here. We can easily see that what we need is our L. So I can say divide both sides. We're going to try and divide both sides by 4 pi square CF naught. Yeah. So divide both sides. So divide both sides by 4 pi square CF naught square. So that will be 4 pi square LCF naught square over 4 pi square LCF naught square is equal to 1 over, actually I knew what to do though, but I'm just trying to make it visible to everybody. Yeah, so that'll be 4 pi square, oh sorry, L won't be there, sorry, L won't be there, L won't be there, CF naught square. Now 4 pi square cancel 4 pi square, CF naught square cancel CF naught square, so I am left with L. And of course, that is 1 over 4 pi square CF naught square. All right. Now, this is not the answer because you have some parameters here, right? So you have to put in your parameters to make your work easier. All right. So let's go now to finish up your work. So I can say that is 1 over 4 pi square, 4 pi square times C. Your C is 10 raised power minus 4. 10 raised power minus 4 times your F naught. F naught is 1000. So that will be 100 all square because you have F naught square. So you can see that that is 1 over 4 pi square times 10 raised power minus 4 times, now you know 100 is same thing as 10 raised power 2, right? So 100 is 10 raised power 2. So 10 raised power 2, let's do something here. That'll be 10 raised power 2 all square. And of course, from indices, you can multiply these two together. That'll be 10 raised power 4. So I can say that'll be 1 over 4 pi square times 10 raised power minus 4 times 10 raised power 4. So you can see now that the work is easier. And of course, from from indices, you can see once you have the same base, you can add up the powers. So when you add up this power minus 4 plus 4 is 0. So this cancel out this guy. Woo. So I can say that is 1 over 4 pi squared. So therefore, my L, that is the inductor, is 1 over 4 pi squared. Very, 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 very easy. And of course, the unit is what? Henry. Is what? Henry. Is what? Henry. So that is the answer to that. So the answer to that is 1 over 4 pi square Henry. All right, guys. So I think we've solved about 2 problems on resonant frequency, and although with different ways of solving that, but that is just the final answer to that. All right, guys.